The first thing we'll be covering today are abstract classes. For this purpose, I have already created a new class which I called bike, and if we head over to it, let me quickly explain what this class does. Our bike class at the moment has two attributes, an integer of the production year and a string of the brand. It has a constructor, which takes in the year and the brand and sets them into the instance of our object. It has a print parts method, which at the moment just prints to the console 3 question marks. And finally, it has two getter functions, which return our production year and our brand. And now we're going to modify our class into what's called an abstract class. If a class is abstract, that basically means it doesn't actually have an implementation of every method, or in other words, it means that at least one of its methods is also abstract, and it just doesn't have an implementation. We will use this concept in our print parts method. At the moment, we just have a generic bike class, and we don't actually know what kind of parts it has to it. So our method is kind of pointless here, and it would be better for us if we would just not implement it. We can do that in a few simple steps, starting by removing the actual body of our method and replacing it with a semicolon. And then we have to add a keyword abstract in front of the return type. So public abstract void print parts. And this actually makes this method to be now abstract, which means it doesn't have an implementation. However, because we have an abstract method in our bike class, we also have to make our bike class to be abstract as well. Public abstract class bike. And this is the way to use the abstract keyword. Now let's think of a scenario of what happens if a class will have a bunch of methods, but none of them actually need the implementation to be in that particular class. Or in other words, what if every single method in a class is an abstract method? Well, we could just remove all of the bodies of those methods and add the keyword abstract, but there is a better way to do it, and that is with the use of interfaces. An interface is exactly what I just described. It's a class without any actual implementations. So for that, let's remove our abstract keywords and let's remove the bodies of both of our methods here, replace them with a semicolon, and now onto the keyword class, which we have to replace with the other keyword interface, public interface bike. Interfaces have a few quirks to it. First off, you cannot create actual instances of an interface, which means that if I would go to my main function, I cannot actually make a new bike instance because it's a bike interface, which means you cannot create objects from it. Another point is that because you can't create objects of it, you cannot give it any constructors. So we're going to have to remove our bike constructor. And the last thing is that you cannot just use private parameters like this inside of an interface. So let's change the access type to be public. And we also need to provide a default implementation to those. So let's set the default production year to be 2000 and the default brand to be a blank string. And that's our interface done. So now let's try and implement it. Let's go to our bike.parts package and create a new class. Let's call it model1. Now to make our model1 class implement the interface of the bike, we use the keyword implements. Public class model1 implements bike. And while implementing an interface, there are two things you have to do. Well, you have to do one of them. The first one being implementing every single method that was in the interface, or making your class abstract so that you don't have to implement every single method, but you can just implement a part of them. We're going to use the quick fix of add unimplemented methods, remove the comments, and let's quickly fix our getters to return the production year and return the brand. Our class model1 has access to those parameters because they are inside of the bike interface and we just implemented it. And now, before we actually define the body of the print parts function, let's talk about aggregation. Previously, we covered inheritance, which basically meant that you can subclass different classes, making things which are other things. For example, a dog could be a subclass of a class animal, as well as a bird could be a subclass of the class animal, and other things like that. What aggregation means is that instead of something being something, our class has an instance of a different class. If we look at our bike again, you can see that our bike has a production year and it also has a brand name. But another thing we can do is we can make our model have other objects. So to demonstrate that, let me quickly first create a wheel class. It's a simple class which just has a diameter, a constructor to set the diameter and a print diameter function. So we can go back to our model now, and we know that bikes have wheels. So with the same concept as the bike having a production year, we can now specify a parameter of type wheel. Let's call it wheel 1, and we can have a second wheel, wheel 2, and now our model 1 can actually have 2 wheels. So let's create a constructor, public model 1, and inside of our constructor we can set wheel 1 to be equal to new wheel with the diameter of, let's say, 30, and we can set our wheel 2 to be a new wheel of a diameter, let's say 32, just different. And now this means that every instance of model 1 we create will actually have 2 instances of wheels, which I actually forgot to make private. So let's now go to our print parts method, and let's call this dot wheel 1 because we want to access the first wheel of this exact instance of model 1 we create, print diameter, which is a method inside of our wheel class. And let's call it again, this time for wheel 2. And finally, to demonstrate that it actually works, let's modify our constructor a bit to take in 2 integers, integer a and integer b, which will be the diameters of the first and second wheel. And finally, we can go back to our main class and we can create new instances of our model 1. Model 1 bike equals new model 1, wheel diameters of 32. We have to, of course, import our model 1 because it's in a different package. Eclipse actually has a really useful shortcut for that. It's Ctrl-Shift-O, and it will automatically import everything which you're missing. And let's create another one, model 1 bike 2, 28. And now that we have our 2 bikes, let's call the method to print parts from both of them. Bike parts, bike 2, print parts, run the program. And as you can see, it prints 30, 32, 26, and 28. Thank you very much for watching. I hope you enjoyed, and I hope to see you in the next one.